Hello and welcome to Vodcast 6.4. In this Vodcast, I'll provide a brief overview of faults and deformations. Although we defined faults in Vodcast 6.1, which was our overview of earthquakes, I'd like to restate that faults are fractures in the crust with appreciable displacement. Shown in this image is what's known as a dip-slip fault, and the fault is labeled with the white dotted line you see running diagonally across the image. With a dip-slip fault, the movement will be parallel to the inclination. For the sake of terminology, we will always label the hanging wall as the rock surface above the fault, and the footwall is the rock surface below the fault. So because this fault is running from left to right diagonally across the screen, the hanging wall is to the top side of the diagonal line, which is why it's on the right, and the footwall is to the bottom side of the diagonal line, which is why the footwall is labeled on the left. With normal faults, the hanging wall will move down relative to the footwall. And normal faults are technically a type of dip-slip fault. In the western United States, you find fault block mountains, and they're associated with large normal faults. There are two other types of dip-slip faults that you should know. In both of these types of dip-slip faults, the hanging wall will move up. Image B shows a reverse fault, while image C shows what's called a thrust fault. The only difference between the two is the fault angle. Notice that for a reverse fault, the fault is really steep and it's almost vertically oriented. To be classified as a reverse fault, the dip angle must be greater than 45 degrees. If the hanging wall is moving up, but the dip angle is less than 45 degrees, it will be classified as a thrust fault. You really should know these pictures, including the normal fault picture shown on the previous slide, and be able to recognize them on both quizzes and tests. The last type of fault that we need to know for the purposes of this course are strike-slip faults. Strike-slip faults are associated with transform plate boundaries, and the San Andreas fault is an excellent example of a strike-slip fault. With strike-slip faults, you'll sometimes find rocks that don't match up with other rocks in the given location. You may find offset stream channels and offset drainage. And after earthquakes associated with strike-slip faults, you can find fences that have been disconnected after the fault slip occurred. The last consideration in this podcast are deformations. A deformation is a change in shape, position, or orientation of a rock mass. Scientists discovered that when stress is gradually applied to a rock, the rock's first response is to deform elastically. But at some point, bending and breaking will occur when the stress exceeds the rock's strength. Shown in this image is deformed sedimentary strata in California. And this image illustrates ductile formation. And ductile formation is the flowing of rock after the elastic limit of the rock has been surpassed. This type of deformation produces a change in the size and the shape of the rock. And as this image shows, with ductile deformation, you can almost imagine the rock is behaving kind of like molding clay, where it can be bent and twisted and shaped. And if you take a look at those lighter colored bands, you see just that. Okay, that concludes this video podcast. In the final video podcast for Chapter 6, we will consider mountain building.